The purpose of this video is to help us to explore the answer to this question. What is the value of 0.9999999 repeating infinitely? Hopefully you know that there's another way to write this number without having to use so many digits. You've probably seen this notation in the past, 0.9 repeating infinitely, and I suspect that you have enough experience with mathematics to recognize the decimal repeating bar over top of the 9, which simply means that the 9s continue to repeat infinitely. So what's the value of 0.9 repeating is what we'd like to discuss a little bit further. In order to do that, let's first talk about how 0.9 repeating compares in size to these decimal numbers, 0.9, 0.99, 0.999, etc. I think you should be able to convert each of those decimals into fraction form, and you're probably ready to answer with the fraction that sits underneath each of these boxes. 0.9 converted to a fraction is of course 9/10. 0.99 converted to a fraction, 99/100ths, and 0.999 converted to a fraction, you guessed it, 999/1000ths. Tuck our little boxes together there on the side. So taking a look at that, I think we could probably say to ourselves that 0.9 repeating, I'm going to insert the repeating bar there above the 9, 0.9 repeating, let me try that again, 0.9 repeating has to be bigger than any of these numbers because we keep adding 9s on and making the fraction larger. What number do these fractions approach if we continue this pattern? Well, I think you can see that the numbers are getting closer and closer to the value 1. But my contention here is that 0.9 repeating doesn't just get closer and closer and closer to 1, but in fact 0.9 repeating is identically equal to the number 1. Now that may sound logical to some of you, and it may sound surprising to others. Let's try to explore it a little bit further and see some ways in which we might be able to verify or justify or possibly even prove that 0.9 repeating infinitely is identically equal to the number 1. Not just closer and closer, but identically equal. And in order to do that, let's go back to some of our knowledge of arithmetic. I think that you probably can agree with me that 0.3 repeating is identically equal to the number 1/3. You've no doubt used 0.3 with the repeating bar as your decimal representation of 1/3 in the past. How do we come to that conclusion about 1/3 being equal to 0.3 repeating infinitely? Well, one of the ways we did that, I'm sure, was to divide, change the fraction into a decimal by dividing. So, of course, the divisor in the fraction is the number in the denominator. That's the divisor. The dividend is the numerator. So we're going to divide 3 into 1. So I have that set up here with our little long division, and of course we are going to carry the decimal point over to the top, and 3 doesn't go into 1, so we take 3 into 10. It goes 3 times, and then we multiply down, of course, and 3 times 3 is 9, and then we subtract. 10 minus 9 is 1. You're following along, I'm sure. We bring down the next 0, and we repeat the process. Again, we have 3 divided into 10, and we get 3. And we repeat our multiplication down. 3 times 3 once again is still 9. We continue the process again, subtracting 1, bring down the next 0. The process continues, as you already know from your experience in mathematics. And we see that the number 1/3, when converted into decimal form, is 0.33333, repeating infinitely. We can do the same thing, and I'm sure you did, with the number 2/3. We can take a look at dividing the number 2/3, converting the number 2/3 into its decimal representation. So again, the divisor is 3, the dividend is 2, so we're dividing 3 into 2. It's 3 divided into 2, of course, does not go, so we have to take 3 into 20. That goes, of course, 6 times. 3 times 6 is 18. And when we subtract now, we have 2 left over. Whoops, that's a terrible 2. Sorry about that. Bring down the next 0. Again, we have 3 into 20 gives us 6 yet again. And you can see what's happening. The process is going to go on infinitely, and the pattern simply repeats itself, and so on and so on and so on. So we do in fact get 0.66666 repeating infinitely for number 2/3. Okay, so this next step may take a little bit of a leap of faith. Try to take this leap of faith with me. If it looks like too much of a trick, we might we'll explore another way to look at the number 3/3, which of course is equal to the number 1. So our dividend is 3, our divisor is 3. I'm not going to say that 3 goes into 3 one time. I know it does, but again, bear with me for just a second. Could we say that 3 goes into 30 9 times? It certainly does go 9 times. 3 goes into 30 goes 9 times. If we multiply down, we get the number 27, right? 3 times 9 is 27. And then going through our process of long division, we subtract, and we get 3 left over. We bring down the next 0 as our process dictates. 3 goes into 30 again. I'm going to say that it goes 9 times. And multiplying down, 9 times 3 is 27. And subtracting 30 minus 27 is once again going to give us 3. Bringing down the next 0 continues the pattern, and again I can say that goes 9 times, and I could simply continue on and on and on like this infinitely, right? So maybe you can agree with me that 0.999 repeating infinitely is another way of writing the number 3/3, which of course is the number 1. Okay, so some of you probably dislike that because it looks like a trick, and it looks like it's not the way we've learned to do our long division. So let's take a look at another possible way of exploring this. We've already talked about the fact that 1/3 is equal to 0.3 repeating infinitely, and 2/3 is equal to 0.6 repeating infinitely. So how about this? What if we simply, oops, that's not what I want to do, so let me take that off. What if we simply add, there we go. What if we add 2/3 and 1/3? Well, we get 3/3, and as we add the digits, 3 plus 6 of course is 9. 3 plus 6 of course is 9, all the way along, and adding each of those 3's to each of those 6's gives us 0.99999 repeating. Another way perhaps of accepting the fact that 0.9 repeating is identically equal to the number 1. Okay, so maybe you're still not convinced. Let's see if a more algebraic approach might convince you. So let's go back to our number 1/3, 0.3 repeating infinitely, and let's label that number x. All right. Now, what we're going to do here is we're going to talk about the value of 10 times that number, 10 times x. What happens when we multiply a number by 10? Basically what happens is that the decimal, oops, I'm not doing what I want to do here. The decimal moves one place to the right, doesn't it, when we multiply a number by 10. So here's what we're going to do. We're going to say 10x is 3.33333 repeating infinitely. All those 3's are still tucked in on the back. And now let's just rewrite our number x below here. X equals 0.33333 repeating infinitely. I'd like to apply now a property of equality, the subtraction property of equality, let's subtract these two expressions, one from the other. 10x minus x is 9x, isn't it? And if we look on the right-hand side, each of the 3's is lined up with another 3 once we get past the decimal point. So all of those 3's cancel out as we subtract, leaving us just with the 3 in the front and the 0, of course. And when we subtract 3 minus 0, we get 3. So 9x is equal to 3. And I think you have enough experience with algebra at this point to know that you solve this equation by dividing both sides by 9. And when we divide the left-hand side by 9, the coefficient of x, which is 9, cancels with the divisor of 9, leaving us with 1x, and 1x in this case is 3/9, which is 1/3, right? Okay, so what we've said now is, in this case, x is equal to 1/3, but of course if you go back up to the top of this screen, you see that x was actually the number in decimal form, 0.333 repeating infinitely. So we've been able to use algebra to show that 0.333 repeating infinitely is the same as 1/3. So let's try that now with 0.9 repeating infinitely. Do you think you can see where we're going to go with this? We're going to take 0.9 repeating infinitely. We're going to multiply it by 10 so that we move the decimal one place to the right. So 10 times x is the number 9.999 repeating infinitely. Writing our value for x underneath there, x equals 0.999 repeating infinitely. And of course, now what do we want to do? We want to take these two expressions and we want to subtract them. Why doesn't that want to stay? Okay, there we go. So when we subtract 10x minus x, what do we get? That's right, 9x. And on the right-hand side, as we subtract, each of the 9's that follows the decimal point has a 9 below it that will cancel out all the way along here. So all those 9's following the decimal point cancel, leaving us with 9 minus 0, which is 9. Okay? You're probably a step ahead of me at this point, and you're ready to really go right to our conclusion here, because we're going to divide both sides by 9 again, and you can see it coming. 9x divided by 9, the 9's are going to cancel out and give us x. And on the right-hand side, we've got 9 divided by 9, which is, of course, the number 1. So what have we done? Again, we've shown that the original x we started with at the top of the screen, 0.999 repeating infinitely, is actually the same as this x down here, 1. So 0.9 repeating infinitely is identically equal to the number 1. I hope you'll give that some further thought, and if you are convinced already, great. If you're not convinced, go back and watch this video again and see if it can make a little more sense to you a second time around.